In some exams, you might see this kind of question. Which of the following is not a unit of energy? Which of the following is not a unit of energy? Option A, joules. B, electron volts. C, Newton. And D, calories. Which of these is not a unit of energy? We are all conversant with joules, that joules is a unit of energy. So correct, it is one of them. Electron volts, I believe this is the first time you're hearing it. Electron volts. Electron volts is actually a unit of energy. We have Newton here. Newton is not a unit of energy. Newton is a unit of force. Unit of force. Calories here is a unit of energy. So the correct option here is option C. Newton is not a unit of energy. It is a unit of force. So this is the correct option, option C. We have question 7. It says, a concave mirror has a focal length of 20 cm. What is its radius of curvature? Concave mirror has a focal length of 20 cm. What is its radius of curvature? Option A, 10 cm. Option B, 20 cm. Option C, 30 cm. And option D, 40 cm. In the question, we are given the focal length. So focal length is equal to 20 cm. It said, what is the radius of curvature? So radius of curvature is unknown. For mirrors, the formula for radius of curvature is given by, for mirrors, the formula for radius of curvature is given by this formula. R is equal to 2F, where R is the radius of curvature and F is the focal length. If we substitute this value into this equation, we have that the radius of curvature is equal to 2 times F. Our F from the question is 20 cm. 2 times 20 cm gives us 40 cm. Therefore, the radius of curvature is what? 40 cm. If you come to these options, the correct option is option D, 40 cm. Question 8 says, what is the speed of light in a vacuum? What is the speed of light in a vacuum? Some persons, when they see this question, they won't even bother go through the option. They already know the answer. Option A, 3.0 times 10 to the power 6 meters per second. Option B, 3.0 times 10 to the power 7 meters per second. Option C, 3.0 times 10 to the power 8 meters per second. And option D, 3.0 times 10 to the power 9 meters per second. When you have this kind of question, recall that the speed of light is a constant. The speed of light denoted with letter what? C is a constant, and the value is 3.0 times 10 raised to the power 8 meters per second. The correct option here is option C, 3.0 times 10 raised to the power 8 meters per second. This is a constant known as the speed of light. Question 9 says, a 12-volt battery is connected to 2 branches in parallel. One branch has 2 series. One branch has 2 resistors, 2.0 ohms and 3.0 ohms in series. The other branch has a single 6.0 ohms resistor. They say find the total current delivered by the battery and the current through the 6 ohm resistor. They gave us option A, 4.0 amps and 2.0 amps. Option B, 4.4 amps and 2.0 amps. Option C, 3.6 amps and 1.8 amps. Option D, we have 5.4 amps and 3.0 amps. Now, what we need to do here, solution. From the question, they said two resistors are in series, 1 and 2 in series. So we say resistors in series, RO series, is equal to RO1 plus RO2, which is this resistor and this resistor. Or better say, let's use the values attached to it for better understanding. Let's see RO2 and RO3. RO2 and RO3. The resistor with 2 ohms and the resistor with 3 ohms. If we add the values together, we have 2.0 ohms plus 3.0 ohms. If you add the both of them together, we have 5.0 ohms. That is our RO series. We have the other resistor which is in parallel to the RO this, which is 6 ohms. So we have RO6 is equal to 6 ohms. This was given in the question. Now from this data now, they said we should find the total current delivered by the battery. Find the total current delivered by the battery. And they said we should find the current delivered or current passing through the 6 ohm resistor. The first thing we need to do, we need to calculate for the current moving through this series connection, which is I series. We know that current is equal to V over R. This is from Ohm's law. The V from the question, voltage is what? 12 volts. So we have 12 volts here. 12 divided by the resistor. Don't forget, this is RO series. RO series is what? 5.0 ohms. So 12 divided by 5.0, we have 2.4. Don't forget, current is measured in what? Amps. So we have 2.4 amps. That is the current flowing through the series connection. For I6 now, for the current flowing through this particular resistor, we have that V over RO6. The V remains 12 volts divided by the RO6. RO6 is what? 6. 12 divided by 6 gives us 2. The unit for current is what? Amps. Let's say 2.0 amps. Now I've gotten the current flowing through the series connection and the current flowing through the resistor with 6 ohms. Able to answer question B that says the current flowing the 6 ohms resistor. The current flowing through the 6 ohm resistor is this. That's the solving we just did, and it gave up what? 2.0 amps. So this particular answer is 2.0. So for B, we have B to be 2.0. Let's solve for A, the total current delivered through the battery. The total current delivered through the battery is given by the formula I total is equal to I series plus I6. We have I series to be what? 2.4 amps. Plus we have I6 to be what? 2.0 amps. So we have 2.0. 2.4 plus 2.0 gives us 4.4. Therefore, the total current flowing through this connection is 4.4 amps. We have A to be 4.4 amps. Now let's come to this question and choose the correct option. The correct option is option B, 4.4 amps and 2.0 amps. So this is our correct answer. Question 10 says a mass of 5.0 kg is attached to a spring with spring constant K 200 Newton per meter. The mass oscillates with amplitude 0.1 meters Find the maximum speed of the mass and the period of oscillation. We have the options. Option A, 1.0 meters per second and 0.63 seconds. Option B, 2.0 meters per second and 0.314 seconds. Option C, 0.5 meters per second and 0.20 seconds. Option D, 4.0 meters per second and 0.157 seconds. Let's solve this. Solution. From the question, we are given mass. They said mass is what? Mass is equal to 0.50 kg. It's attached to a spring, the spring constant. They give us spring constant. Spring constant K to be 200 Newton per meter. The mass oscillates with an amplitude. They gave us amplitude A to be 0.1 meters. They say find the maximum speed. So Vmax, we don't know Vmax, is unknown. And they also say we should find the period of the oscillation. C, capital T, is also unknown. Recall that Vmax, which is the maximum speed, is equal to angular frequency times amplitude. This is the formula for Vmax. The maximum speed is equal to the angular frequency times the amplitude. We know the value for the amplitude, but we don't know the value for angular frequency. So we recall the formula that angular frequency omega is equal to square root of K over N. From the question, we have that K, the spring constant, is 200 divided by the mass from the question is 0.5. W is equal to square root of 200 divided by 0.5 gives us 400. Square root of 400 gives us 20. Therefore, the angular frequency is equal to 20. Now we have gotten the angular frequency. Let's substitute it into this equation. We have that the maximum speed, Vmax, is equal to omega. Our omega is 20 times our amplitude A. Amplitude is 0.1. 20 times 0.1 gives us what? 2. The unit for speed is what? Meters per second. So we have gotten the first one, the maximum speed to be 2 meters per second. The next part of the question says the period of the oscillation. Period, capital T, is equal to 2 pi over omega. This is the formula for period. Here we have 2 pi over our omega from the question is what? 20. So we have 20 here. 2 divided by 20, 2 goes there 1, 2 go here 10. So we have this is pi over 10. Pi, we know pi to be 3.142, right? Divided by 10. Divided by 10. 3.142 divided by 10 will give us 0.3142. This is in seconds. Therefore, we have the maximum speed to be 2 meters per second, and we have the period to be 0.3142 seconds. The correct option here is option B. The maximum speed is 0.2 meters per second and the period T to be 0.314 seconds. We are done with today's class. Please don't forget to like, subscribe, and share with friends. See you in our next video.